Number 11. Well, I want to figure out n's value is going to make this a true statement. To do that, I need a common denominator for everybody, and then I'll set the numerator left equal to the numerator on the right. So I got an n. I got an n plus 2, and I got an n plus 3. The only common denominators, we're just going to multiply every one of them together. In other words, the common denominator is going to be an n times an n plus 2 times an n plus 3. So let's start with this n. He needs an n plus 2, and he needs an n plus 3. So this top is going to get multiplied by an n plus 2 and an n plus 3. All right, the n plus 2 needs to be multiplied by an n, so he's going to get multiplied by an n. And he needs to be multiplied by that n plus 3. So he's also going to get multiplied by an n plus 3. This guy needs to be multiplied by an n. So we multiply the top by an n. And the bottom needs also an n plus 2. So the top is going to get an n plus 2. So the common denominator for the bottoms are all n times n plus 2 times n plus 3. See, n plus 2, n plus 3, n plus 2, n plus 3. That means I can now, since the denominators are all the same, I can set all of this on the top equal. So here's what I have. I have 2 times an n plus 2 times an n plus 3 plus now this part, 4n times an n plus 3 equals the 6n times n plus 2. All that's going to be true. Okay, and I don't need the denominators there anymore. I just can set this and solve it for n. So let's see. Now, first off, I have a 2 times this times this. I have 3 things to multiply. If you have 3 things to multiply, it doesn't matter the order in which you do it. I think it's always wisest to go ahead and multiply binomial times binomial instead of doing the 2 times each piece and then doing it. So we're going to have 2 times, what's this going to give us? N times n, we can see is n squared. You should be able to see you're going to get 3 in there plus 2 in there, which is going to give you a grand total when you put them together, 5n. And then 2 times 3 is a 6. Plus, let's go ahead and distribute through here. It's going to give me 4n squared. 4n times 3 is 12n. Over here, 6n times n is 6n squared. 6n times 2 is 12. N. Almost left my n off. Critical mistake. Must distribute the 2 through. So you get 2n squared. 2 distributed through here is 10n. 2 distributed through here is 12. And then I still have to add 4n squared. Have to add 12n. It equals the 6n squared plus 12n. Yes, I get tired of writing 2, but it's only a few extra seconds. 2n squared plus 4n squared, 6n squared. 10n plus 12n, 22n. And then just the number 12 equals a 6n squared plus 12n. Now, notice you have a 6n squared on the left, a 6n squared on the right. So it's nice that when I subtract a 6n squared from both sides, they go away. And you're left with 22n plus 12 equals 12n. Now, you can either bring your 12n over to the left and then the number 12 over to the right, or I would just subtract 22n to start. This gives me the number to the left, and on the right, I'll be left with negative 10n. Now divide by negative 10, divide by negative 10, n equals a negative 1.2 is what most of you are going to give me, negative 1 1/5. But this is beautiful, makes me super happy if you get that. You can see it's a long problem. You just got to take your time and keep going at it, going at it, going at it, and you'll get there to the negative 1.2 answer.